with part 1 of problem number 1. We're identifying the parameters. So n is 60, p is 0.8, and then the probability of failure is 0.21. And then, sorry, I'm looking at the question. So the n60, that is the number of trials, or like number of shots. And then the 0.80 is the probability of making the shot. And then the 0.20 is the probability of missing a shot. So that's pretty simple. That's one of the easier questions. And then next, we're asked to find the mean and standard deviation. So I went ahead and wrote out the formula. So then we'll plug this in. So it is, we'll do the 60 and 0.8, which is equal to 48. And then next, we'll fill out this one up here. So it'll be 60, 0.8, and then that 0.2. And then we'll square that. And then that'll be, let's see, like roughly 9.6. And the square of that is roughly like 3.10. So the for the interpretation of this, on average, she'll make about 48 shots. And then with a typical variation of 3 shots over time. So that's this number right here. And then next, part 3, we're going to do the check for normal approximation. And I went ahead and wrote out the little formula things. So if the numbers are greater than or equal to 10, then it'll be appropriate, or technically I guess satisfied. And if it's not, then it won't be. So if you plug in, so this is going to be 48 right here, and that is greater than 10. So that one's good. And if we do this one, it'll be, when we plug in our numbers here, it'll be 12. So then 12 is greater than 10. So then that one's good too. So let's check out. They are satisfied. And then part 4, well, I have the thing I have it filled out already right here. So we'll put in our numbers from the z table. So we'll get 0.48. And that's going to be equal to 1. And then we'll subtract that. We get 0.3156. And then, so the probability that she makes about 50 shots is like, I think when I calculated it, it was about 31.6% chance. Yeah, there we go. And the percent symbol goes this way. Period. Awesome.
Alright, so problem 2, I have the formula written out already, so we'll just plug in those numbers. 12 and then square root of 36, that is 12 over 6, and that is 2. So with the sample, the sampling distribution has a mean of 60, which is right here, and then the standard deviation of 2. So that's easy enough. And then for part 2, we're going to find the z-score, and I have the formula written out here again, and then we'll plug in our numbers, 63, 60, and 2, and that is 1.5, and that's, so we'll do 1 minus 0.9332, and that is roughly 0.0668. So the probability is about 6.7%. And I have my z table pulled up, so that's where I got the numbers from. Period. So that's that one. And then we'll flip over to this side.
Alright, and then starting on this part, this is the graph on problem 2. I had to start on a new page. So I went ahead and wrote out like the numbers on everything. So the mean for this is 60, so that'll be the middle right here. And then we can go ahead and start. We'll start at 54, so like right here. And then put a point at 62, so like right here. And then this is like, I find this easier, like an easier way to get like my like line straight. So I'd start like here, and then go, this will be the top, and then curve down like that. I'm not an artist, so you can't judge me. There's that. And then we're going to shade from 63, which is like, say like right here, I guess, I can make 63, and we're going to shade over this way. Period. And then we're going to move to problem 2, part 5. 1 second, I'm trying to get my notes that I had written out. Let's see. Problem 2, part 5. So next, we're going to find if the sample size would increase to n at 100. So let's do that. We'll do 12 over square root of 100. And that's 12 over 10. And that's 1.2. So the smaller standard deviation is less variability in the sample means. So this means that the sample mean will be closer to the population mean in that case, if that's 100. So now we're going to move on to number 3. Let's see. So we're given 3.15, 0.40, and 50. So I have our little formulas filled out already. So I'm going to plug in my numbers. We'll put the 0.40. We're finding the standard error, by the way. And then that's going to be 50. And this will be 0.40, 7.071. And then that is 0.0566. So that's the standard error right there. And now we're going to find the margin of error. So this one we're going to do 1.96 times 0.0566. And that is equal to 0.115. So that's that. And then now we're going to construct the interval. So I have 3.15 and then 0.111. So that'll be 3.039 and 3.261. So that's about 95%. Awesome. And then for part 2, we're doing the interpretation. So that's just that we're 95% confident that the true population. So I'll put that 95% right there. So that's that. And then for part 3, I'm going to sketch the interval. Yeah, we're on problem 3. So I went ahead and wrote my numbers out, so I'm going to start putting my points and then going from there. So that lower is 3.04, so put like, I guess like here would be fine. Yeah, that seems okay. And the mean is at 3.15, so we can put that up at the 7. And I just went up to 10 because I had room, so yeah. And then we'll go 3.26 over here at the bottom. And then we'll sketch it from there. Oh, I told you I'm not the best artist. I try my best. And then we'll shade everything on the inside, so that 95%, that's what we're going to shade. So it'll be like a little, like right here, and then like a little above 3.25. And then everything on the inside will be shaded. Everything on the inside in between. So that's that 95%. Oh my gosh, it scared me, sorry. That was my phone. Gosh, that scared me so bad. Okay, now we're going to move to part 4. Let us see. Oh, part 4, construct the interval. Okay, so I accidentally wrote, this part I accidentally wrote right here. So we're going to cross this out. So for part 4, we are comparing the width. So if it's a 95%, that's obviously going to be smaller than a 99%. I feel like you don't really have to, do too much thinking with that. And then, so with a wider interval, there will be a higher confidence because there's a bigger, like, highlight space, I guess you could say. So it'd be like, yeah, that's how you can look at it. This is bigger than this. That's the easiest way to put that. And then for part 5, I went ahead and wrote out the formulas again. So I'm going to fill in the numbers. So 0.4 squared root of 100, and that's 0.04. And then for this, it's like 1.96 times 0.04. That is 0.078. So there's that. And then we fill this out again, 3.15. And then this is, gosh, this is doubling the sample size. So n would be 100. That's what this is, by the way. And then we're going to do 3.15, yeah, and then 0.078. So then that'll be 3.072 and 3.228. So if it's a bigger sample, the interval is going to be narrower, since the standard error here decreases. And then now we're going to move to problem 4, which I have right here. I'm going to pull up the problem real quick. Problem 4, state a null and alternative hypothesis. Okay. So for the hypothesis, we're going to do, I guess this is in 12, which is the company's claim. Sorry, I forgot I'm holding it. So that's the company's claim. And then the customer group suspects less than this number. So it's a left side test. And then 2, we're going to need a formula. So I have it written out for us, and then I'm just going to fill in the numbers, and then we'll calculate that way. So 11 minus 2 minus 12, 0.24, and it's 49. And then when we compute that, when we do all of that, we get negative 211. That is our z. Easy enough. And then for part 3, we're going to find the p-value. So z has to be less than negative 211. And that's, when we look at the table, it's 0.0174. So that's also easy enough, so this is p. And then for part 4, it's going to be left-tailed. So that means that wherever we draw, we're going to have, it's going to be shaded to the left and not the right, or like anywhere in between. So I'm going to go ahead and put my point at 0 and up here. So that's, here's one right there. And then we'll go like this and like this. Try my best, just not the best artist. And then we're going to go z negative 211. So like right here, I guess. And then we'll shade this way, because it's the left skewed, I guess you could say. So we'll shade that way, period. And then, now we are moving to problem, what's it problem 4? Oh, what does the p-value represent in this situation? The p-value represents, let me see what I wrote, sorry. Yeah, the p-value represents that there's only like a 1.74 chance of getting the sample mean. If the true mean were 12. So it's true, there's strong evidence that the company's claim is not accurate. So next we're going to go to problem 5. And the hypothesis, I think it's a two-tailed test. Because it says changes the mean. That's what I got from that. Yeah, so that's just briefly explained. Complete the test statistic 2. Oh, here we go. So I have this filled out again. So then now I'm just going to put in the numbers like I've been doing. So we'll do 194, and then 200, and then 20, square root of 15. And then when you do all that, you get negative 1.16. So that's, excuse me, yeah, that's the test statistic. So that's easy enough. And then, check or, one second. Oh, so for part 3, sorry, I don't have the calculator right here. For part 3, we're going to find the degrees of freedom. So we'll do degrees of freedom plus n minus 1. So that'll be 14, which is also easy enough. That's a very easy thing to compute. Doesn't take too long. And then next we're going to find, on our t-curve, we're going to fill that out. And we're on problem 5. So this one's a little different. I'm going to put my points, and then I'll do the little curve like I usually do. So 0, ready? I wish I could draw these better. And then we're going to want the t at negative 1.16, so like here, I guess, that'll work. And then critical t at like 2.1-ish, so like a little over 2 right here. And then we'll shade this part in right here. in just this part. It's not like all one side, all to the left, or all to the right. It's just this part, which I actually like that. I like how it looks. I think that's like satisfying to me. But, and then for part 5, oh, well this will actually be part 5. Sorry, I just think that on part 4. Part 5. This will be part 4. Let's jump back to part 4 and grab them at 5. And then, look at this.
Okay, sorry, I lied. So this is actually part 4. I just had my notes mixed up. So now we're actually going to do the part 5. I'll speed this part up because this might take me a second. Yeah, so I'm going to do that really fast. So this will be like 170, 180. Alright, so the sample mean is like 194, so we can put that like right here, I guess. That's like 194-ish. I'm not very good at like estimating stuff like that. The lower is 182-ish, so then we can put that like right here. That can be like our lower point, and then the upper is like 205, so then we can put that like in between these two. And then this will be like the best one that I draw, probably, hopefully. Yeah, I hope so. Okay, let's try. So we're gonna go like this, and we're gonna connect these, and then we're gonna go like this, and then connect. Well, that's actually pretty good. And then we are going to shade in between these, this and this. Everything in here would be shaded. I don't have any highlighters. I would use a highlighter, but I don't have any. So this is all going to be shaded. And this is part 5, by the way. So since 200 is inside the 90% confidence interval, it matches what the t-test said. But I don't have enough evidence to say that the diet changed the average or anything like that. So, and then let us see. Is there a part 6 on this question? Sorry, let me find the worksheet I left. Oh, here we go. So the summary for it, the t-test is used because the deviation is unknown and n is small, and then the t-distribution is wider than the normal one, and then the data doesn't show a significant difference from 200. It's not like anything crazy, so it doesn't really, yeah, it doesn't really affect it too much. But